Good morning, everybody. Today we're going to go through the lab that we'll be doing tomorrow. So it's a really fun lab. If you want to do it at home, you just need a few materials. So I'll go through the material list really fast, and then I'll tell you. No, sorry, I lost my screen. Go back to that for a second. There we go. Let me go through the material list with you all if you want to do this on your own. So you're going to need baking soda, vinegar, a teaspoon, a tablespoon. And then either a sandwich bag or a quart-sized bag. And then gather the materials for tomorrow, and then we'll do the lab together if you have the supplies. And if you don't, then I'll do it and show you all. Okay, so we're going to mix baking soda with vinegar tomorrow. Let's go through the reaction. So vinegar is acetic acid. That's CH3COOH. And that reacts with baking soda, which is NaHCO3. So we have vinegar. And vinegar is actually mostly water. It's 95% water and 5% acetic acid. And react that with baking soda. And baking soda is pure sodium bicarbonate. So you probably have all done this before, and you get fizzing. You see bubbles form when you mix baking soda with vinegar. And that's carbon dioxide. You also get some H2O. And then sodium acetate. Which you don't really see in the reaction because it dissolves in the water. So at the end, what you'll see is a clear solution, which has water with sodium acetate, and then bubbles form, which is the carbon dioxide. So this is a balanced reaction. Everything is a 1-to-1 ratio. So for every 1 mole of acetic acid, you need 1 mole of baking soda to react with it completely. So what we're going to do tomorrow is determine how many moles of baking soda you need to react with vinegar to fill up a sandwich bag completely full without it popping. So the idea is to calculate the exact amount you need to get the bag full without popping the bag. So if you have a sandwich bag, I think it's funner with a quart-sized bag because they're bigger, but sandwich bags work just fine too. The volume of a sandwich bag is 0.650 liters. For a quart-sized bag, it's 0.946 liters. And so that will determine the volume of gas you need to make to fill up the bag completely with carbon dioxide. Okay, so using that information, and I'll just use the quart bag as the example, but the sandwich bag can be used if that's all you have at home. But I'll use a quart size in my calculations for today. Remember yesterday we talked about Avogadro's principle, and he said that 22.4 liters of gas equals 1 mole of gas. So we'll use that conversion. And if we know that that's true, if we know that 22.4 liters equals 1 mole of gas, we could determine how many moles of carbon dioxide we have to produce. So if we have a sandwich bag that's 0.946 liters full, we need to know first how many moles of carbon dioxide will fill up that bag. So if the bag is 0.946 liters, we'll multiply it by this unit multiplier right here. For every 1 mole, it's 22.4 liters. So we do 0.946 divided by 22.4, and that gives us 0.0422 moles of carbon dioxide. So that would be for a quart-sized bag. If you have a sandwich bag, then use this one instead, the 0.650 liters. So now what we know is that we need to produce 0.0422 moles of carbon dioxide to fill up the bag completely with air. So the question would be, how many moles do we need of acetic acid and a baking soda to do that? Well, we can see on here that it's all a 1-to-1 ratio. So if we produce 0.0422 moles of carbon dioxide, then we also would react 0.0422 moles of baking soda with 0.0422 moles of vinegar or acetic acid. You with me so far on this? Okay, so the first thing we'll need to do is find out how many grams of baking soda that is. So we need to convert 0.0422 moles of baking soda into grams. So we go to the periodic table, look up sodium, that's 22.9, hydrogen is 1.01, carbon is 12, oxygen is 16 times 3. Add that all up and you get 84 grams per mole. So we need 3.54 grams of baking soda. Now you might wonder, how can you measure out grams if you don't have a scale? Now, if you have a scale at home, you can use your scale. But if you don't, there's a simple conversion you can use to go between grams to teaspoons. I'll write it up here for you. So 1/4 of a teaspoon is equal to 1.6 grams of baking soda. So we can convert between baking soda grams into teaspoons by doing that. So we could take 3.54 grams, which is what we need, and divide it by 1.6 grams. Let's see what that gives you. So do 3.54 divided by 1.6. And we get 2.2. So you could do about 2/4 teaspoons of baking soda to get the required amount that you need if you don't have a scale. Now, if you have a kitchen scale, that's better. I would use that instead. But if you don't, you can use this conversion up here to go from grams to teaspoons. So that gives you roughly what you would need to use of the baking soda. Now let's go into the vinegar. So that one requires a bit more steps because vinegar, you can't weigh out the same way you do with baking soda. It's a liquid. And vinegar is not pure acid. It's only 5% acid. So the conversion we can use for this one, I already did some of the calculations for you for the vinegar. We can just take a shortcut And what we can say is that in 1 liter of vinegar, there's 0.833 moles. And that'll just make things easier for you. So use this unit multiplier. 1 liter equals 0.833 moles. Now we need 0.0422 moles of vinegar. So let's see how many liters we need of vinegar. So we'll take 1 liter and divide it by 0.833 moles. The moles cancel out. So do 0.0422 divided by 0.833. And that gives us 0.0507 liters. Which is also 50.7 milliliters. So if you have a milliliter measuring device, you can use that. But if you don't, then you can convert to teaspoons. I'm going to write this up here. So 5 milliliters is equal to 1 teaspoon. And if we need 50.7 milliliters, we want to go to teaspoons. We would use this conversion right here. So 50.7 divided by 5 gives you about how many teaspoons you would need to use. Let's see what that gives you. So roughly 10 teaspoons. Now, tablespoons might be easier to use because they're bigger. And the conversion between milliliters to tablespoons is 15 milliliters in 1 tablespoon. So I'll write that down here too. So we can say in 1 tablespoon, 15 milliliters is 1 tablespoon. So 50.7 milliliters times 1 tablespoon divided by 15 milliliters. Let's see what that gives you. Actually, you know what? One thing that would even be better would be to think of it this way, that for every 15 milliliters, that's 1 tablespoon. 15 times 2 gives you 30. 15 times 3 gives you 45. So 3 tablespoons gives you 45 milliliters. 1 teaspoon gives you 5 milliliters. So what you could say is this, that 3 tablespoons plus 1 teaspoon gives you 50 milliliters. Probably would be the best way to convert it. All right, so that's the calculations you'll need to do for the lab. If you want to do the lab tomorrow, what I want you to do is figure up on your own how to fill up your bag. And so if you have a different size bag, then figure that out for yourself. So I did the quart size bag. If you have a sandwich bag, figure out how to do the sandwich bag. Write down what you need for baking soda and vinegar. And tomorrow, either you can bring your own supplies. If you don't have them, you can tell me and I will do it for you. And so you can see what would have happened with your equation. Any questions about that? Okay, we'll meet again tomorrow and we'll do the lab. Have a good day, everybody.